Standard normal calculations. As suggested in the previous section, all normal distributions share many common properties. In fact, if we change our units to just 1 sigma and center the graph at mu equals 0, then all normal distributions would be exactly the same. This is called standardizing. If x is an observation from a normal distribution with a mean of mu and a standard deviation of sigma, the standardized value of x is called the z-score and is computed with the formula z equals x minus mu over sigma. A z-score will tell us how many standard deviations the observed value falls from the mean. We can use z-scores to standardize values that are on different scales in order to compare them. For example, Bond took the ACT and scored 31. Craig took the SAT and scored 1390. If both tests are normally distributed, who did better? We're given the ACT mean and standard deviation and the SAT mean and standard deviation. So we will standardize each score. Bond's standardized score would be his score minus the mean divided by the standard deviation. This gives a value of 2.106. Craig's score was 1390 minus the mean divided by the standard deviation. This gives him a standardized score of 2.178. Craig scored higher in the standardized scores than Bond did. This means he was a little further away from the mean. The standard normal distribution is the normal distribution where the mean is 0 and the standard deviation is 1. For continuous distributions, remember the probability that x is equal to any value is 0. So saying less than or equal to is the same as a strictly less than, and greater than or equal to is same as a strictly greater than. These are the commands for RStudio and the TI-83 and 84 calculator. For the probability that we're less than a certain value, we use p-norm in RStudio with our value, our mean, and our standard deviation. Remember, if this is standard normal, then our mean is 0 and our standard deviation is 1. When that's the case, these two values are optional. The p-norm command could take just one parameter. For a greater than, we need the complement. We'll do 1 minus p-norm, and for an interval, we have to subtract the large value minus the smaller one. With the TI-83-84, we use the normal CDF command, and remember with normal CDF we have our low value, our high value, and then the mean and the standard deviation. And likewise, if we have a 0 and a 1, it defaults. We don't have to put those in. If we have standardized values, z-scores, we could use the table for z-scores to get our probability. For example, if we had a z-score of negative 2.94, I could get the probability that z is less than this from the table. I look down here for negative 2.9 and I go across to 0.04 and I see that the probability is 0.0016. Let's find some probabilities. The first probability was the probability that z is less than negative 1.06. Let's scoot this over so we can see everything. So I'm going to go to my distribution menu, go to normal CDF. Our lower limit is defaulted. Our upper limit is negative 1.06. Mean and standard deviation default are 0 and 1. When it's z, those are my means and standard deviation, always. So my probability is 0.14457 or 0.1446. Now for the probability that z is less than 2.15, distribution menu, normal CDF. Now, if we remember what our normal curve looks like, and we remember that our empirical rule told us how far we are away, what our intervals are, we should get a good idea that this should be a large percentage. We are above the mean here, 2 standard deviations above the mean. The mean is at 50%. If I go 2 standard deviations over, I should have a probability much higher than 50%. 0.9842. Now I can find the probability that z is greater than 2.15 without going back to my calculator because it's the complement of our probability in part B. So I'm going to use my probability rules and subtract. And when I have an interval, I can use my calculator, or I can subtract the larger probability minus the smaller probability, which will be 0.9842 minus 0.1446, which gives me 0.8396. On the calculator with the normal CDF, my lower limit is the negative 1.06 and my upper limit is the 2.15. Now let's look at a distribution that's not centered at 0, not standard normal. So this is our mean, 100, and this is our standard deviation, 15. One way to do these is to standardize them. If we needed to use the table, we would have to standardize them, or we can input our values directly into the calculator, and I'll do this both ways. If I standardize this probability would be the same thing as the probability that z is less than our standardized value, which is x minus the mean over the standard deviation. And when I plug this into the calculator or another device or look on the table, I would get 0.0918. Now again, in the calculator, I don't have to standardize it. This is a less than, so my lower limit would be some very small number. My upper limit is 80. My mean is 100. And my standard deviation was 15. Slightly off from my standardizing. The probability that x is greater than 105, 105 would be my lower limit. Large number, 105 for my lower limit. My upper limit would be a large number, Mean and standard deviation are still in there. 0.3694. And last for this one, we're between, so my lower limit is 80, my upper limit is 105, .5393. If we know the percentile rank C and we wish to find the z-score, we use the following commands. The command for RStudio is qnorm, and with the calculator it's inverse norm. We input our percentage, then our mean, then our standard deviation. The percentage differs based on our probability statement. If we have a less than probability statement, then we enter the percentage as is. For a greater than, we need to use the complement. This is true for both. When we're working with values in between, then we are looking at this part of the standard normal. Let's say that I want between negative C and positive C. So we have this probability right here. We'll call it P. Now remember, the qnorm and the inverse norm are looking for the probability such that the area to the left of our value is what we have. If we're given this probability, we want to add what I've shaded in blue to this value shaded in red. The entire area under the curve is 1. So the two tails together are equal to 1 minus P. So I need this tail right here only, which will be half of those two. So we're going to add this value back to P, and when we get a common denominator and simplify, we're left with P plus 1 over 2. That gives me this entire probability so that I can find my value of C. So let's find some values. We're going to use the calculator, so we'll input inverse norm, and the values that we're going to input will be the same for RStudio. We would just use the qnorm command instead of inverse norm. Inverse norm is found under the distribution menu. When we have a less than, we enter the probability as it's given. If we have z's, we use a mean of 0 and a standard deviation of 1. So our value of C is 0.7402. Now for a greater than, we have to use the complement. So when I enter into inverse norm, instead of entering the 0.006, my area will be 1 minus 0.006. So our C value here is 2.512. Let's look at this quickly on the graph so you can see that this makes sense, that C is giving me these values. These are standardized since we're working with Z's. These tell me how many standard deviations we are from the mean. Remember, a standard normal centered at 0. If the probability that Z is greater than C is 0.006, it means it's very, very small. Greater than would be shaded this direction. So this area right here is 0.006. And that would make sense to be about 2 standard deviations or more from the mean. Now on the last part of this question, we want to find the value of C such that the area between negative C and positive C is 0.966. So this area right in here is 0.966. If I subtract 0.966 from 1, I have 0.034. So each tail is 0.034. If I divide that by 2, I have 0.017. And that's what each tail is. So the probability that Z is less than the positive C would be 0.966 plus 0.017. And I could enter this value into my inverse norm, or we could use the formula that I discussed on the previous page. And we would enter it this way. Parentheses, our probability, plus 1, close parentheses, divided by 2. And the calculator and RStudio both will do the calculations for you. Just make sure you have your parentheses in the correct place. And we get an answer of 2.12. Suppose you rank in the top 10% of your class. If the mean GPA is 2.7 and the standard deviation is 0.59, what is your GPA? So I want to find the probability that X is greater than some value X to be 10%. Now this is the same thing as saying less than is 90%. So I'm going to use my inverse norm, or in RStudio Q norm. I'm going to enter 90% for my area. My mean though is 2.7, and my standard deviation was 0.59. And I get 3.46, I believe. Yes. Now, if I only had the table to look this up, this table is standard normal. So if I used the table and found the probability that Z was less than some value to be 0.9, then I would get a Z-score of 1.28 approximately. This is the standardized value. This is telling me how many standard deviations we are from the mean. So I would take that Z-score and set it equal to my formula, X minus the mean divided by the standard deviation, and I would solve for X.